Okay, so in this part of the experiment, you are going to now do an experiment comparing the effect of sunlight on the productivity or the amount of algae that's produced in each pool, and therefore how many catfish live in a shaded pool versus a sunny pool. So in this part of the investigation, you're looking at two pools, Bat Rocks and Cess. They have different amounts of tree canopies, so they have different amounts of sunlight. We can see on the left, this one looks a lot sunnier. The one on the right looks a lot shadier. You're going to make a prediction about which pool you think has the most algae. And you're also going to use this graph. This graph shows on the bottom the percent open canopy, which is another way of measuring how much sunlight there is. So the canopy is the trees. They block the sun. More open canopy means more sunlight. So over here, this one has the most sunlight. And then your y-axis is the grams of algae per meter per day. So how much algae is growing every day in a given meter, square meter. This graph shows some data. So you're going to use that graph to make a prediction about the standing crop of algae. Anything in yellow you can click, and it tells us that the standing crop is the total biomass of an ecosystem or its component. So here we're talking about the total biomass of the algae at a given time. So at any given moment in time, not, over a week, how much algae is there? Is it the same? Whether or not there's a small amount of sun or a lot of sun, I just randomly guessed C. That has nothing to do with whether C is right or not. Is there less algae the more sunlight there is, or is there more algae the more sunlight there is? So you're going to make your guess for those. And then you're going to, again, make your prediction of which pool you think is going to have the more algae than the other. Again, my guess is just random, just to demonstrate. Okay, so then you're going to scrape. So at this point, you're going to click on those to close. You can click your scraper tool, scrape, 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 scrape. Same thing as before until this is above 0.75. You can scrape both pools at once, return your scraper tool. And then you're going to do some calculations. So unlike the first calculation, in this calculation, you are comparing 1 meter squared on the left to 1 meter squared on the right. So even though we're still assuming 30% algal coverage, we do not need to extrapolate to the whole pool. So we don't need the surface area of the pool because we're just comparing a square meter on the left to a square meter on the right. So what you are going to do is just the part to figure out grams per square meter, which means you divide the grams on the bottom by the square meters on the top. It's in the reverse order. Don't let that confuse you. So your smaller number, the biomass collected, the one that's on the bottom, the grams, divided by the one on top point. For me, 0.791. Yours is going to be different. And that will give you how many grams per square meter of algae you have in that pool on the left. Okay, then you will repeat that exact same calculation down here. I'm going to just put in a random number. And then you're going to check and look at your prediction. Which pool had a bigger number for the standing crop of algae, the one on the left with more sun, the one on the right with less sun? Does that match which pool you predicted was going to have more algae? Again, I'm just putting random numbers or answers. Okay, so here you're going to look at these results, write a hypothesis that explains how catfish might be impacted by light availability. Hypothesis. And you're going to now count the catfish in each pool. And at that point, you're just going to continue writing a summary of your results, comparing for the next question what you found to what you expected. And at the end, it will generate a PDF for you to turn in.